It is now the third day of Krasheninikov's somewhat unexpected explosive eruption, which was triggered by the July 30th magnitude 8.8 earthquake. After all, the volcano's magma chamber experienced MMI 6 shaking, which is equivalent to the motion seen in this simulation. As the eruption has progressed, I have both bad and good news. The good news is that the magma dike which propagated and fed a flank vent to the northwest has seemingly stopped its forward motion, meaning that for now, the possibility of additional vents popping up further away from Krasheninikov's northern cone is rapidly decreasing. The bad news is that the eruption shows no signs of weakening, and in fact its surprisingly modest eruptive rate and behavior suggests that we might be in for a lengthy eruption, perhaps spanning several weeks or maybe even several months. And while ash emissions have been continuously ejected to an altitude of 20,000 feet, prevailing winds have caused these to drift far to the east away from any large-scale regional airports. This means that while some flight disruptions could occur, they are less likely than if, say, hypothetically, Avichinski decided to erupt simply due to the location of both volcanoes. While I had assumed that on day 1 Krasheninikov's eruption was magmatic, now we have conclusive proof. As, after its north-northwest flank vent lengthened, it gave way to a growing blockade lava flow that has so far traveled as much as 1,400 meters or 0.87 miles from its source vent, covering an area of 0.37 square kilometers or 91.4 acres. This lava flow at most only contains 747,000 cubic meters of lava, suggesting a very low effusion rate of only 4.32 cubic meters per second. It seems that so far, the vast majority of what material is erupting is being propelled upwards by sufficient volumes of gas that rapidly expand as they rise to the point that magma rising with it fragments to such a degree at other vents that it becomes primarily fine particles of ash. But back to the lava flow, it is actually surprising for two reasons. The lava being emitted is both unexpectedly thin and unusually dark. Based on this, it appears as though the current eruption is either high silica basalt or low silica basaltic andesite. And I say this because with the 5 most common lava types, generally speaking, the darker the lava rock is, the less silica it contains by percent weight. This is a bit strange because Krasheninikov's northern cone is largely constructed out of more viscous andesite lavas, but I could still be misidentifying this expanding lava flow, which could technically still be andesite compositionally. For now, the lava effusion should continue, slowly spreading out and expanding until it reaches the northern rim of Krasheninikov's largest caldera. Moderately explosive activity should also continue. Eruptions at Krasheninnikov seem to occur in clusters across 1,000 to 2,000 year long periods during which the silica content of lava starts low and then progressively increases, or at the very least becomes more capable of producing more silica-rich lavas for the most part. Thus, it might make sense for it to be actively erupting basalt if we truly are at the beginning of a period that will see Krasheninnikov erupt multiple times in the next millennia. However, I want to note a strange peculiarity. Do you see that volcano to the south? That is known as Klyuchevskoy. For some reason, the margin of error on the dates of it and Krasheninikov's last 6 eruptions overlap in each case. This means they could have erupted at the same time during the last 6 instances, but this could be a coincidence from a small sample size, regardless still warrants further study. Meanwhile, the last 24 hours saw eruptive activity increase again at Klyuchevskoy as its violent Strombolian eruption continued, creating 250-meter-high lava fountains at its summit. These all originated from a now 45-meter-high summit cinder cone, which has generated ash emissions that rose to as much as 30,000 feet altitude. Lava effusion is ongoing at a much higher rate at Klyuchevskoy than Krasheninnikov, involving less viscous lava that has already traveled 3,600 meters down its west-southwest slope. Stay tuned for more updates. As a final note, I would like to thank my new patron Hilbert Spaceman for supporting my work.